This is a scale EV for automotive application. And we want to show how this is supporting your design for functional safety and simplify your application. I've taken the time to draw this and explaining an active discharge function integrated in our scale EV board. The active discharge of an 800 volt, in our example, DC link is possible with an active turn on of the top and bottom IGBT or silicon carbide. To avoid a short circuit between the top and the bottom, we are reducing the gate turn on voltage from, in our example, 15 volt to 10 volt, actively controlled by the scale EV automotive gate driver. To activate this function, we are applying on the digital logic input signals a 5 volt, and we are applying on the input plus a frequency, turning on and turning off the gate. Additionally, we need to turn on our top IGBT by the regular PWM input. And in this case, a current is flowing and limited by the bottom devices because of the switching frequency and because of the lower gate emitter or gate source by a silicon carbide MOSFET gate source voltage. Now I have drawn this picture, what explaining an active short circuit. The active short circuit take out the energy of a rotating motor by short all the three phases U, V, W. To short the three phases, we are turning on the bottom side IGBTs or the top side IGBTs. In my example here, I'm turning on the bottom side 3 IGBTs or silicon carbide MOSFETs. And for that one, I apply a 5 volt digital logic signal to our ICAD digital input pin, and at the same time, a 5 volt logic signal to the ASCAD-EN digital logic input pin. With priority, we are turning on the gate, and in the moment where I do this with all 3 button scale EV gate drivers, I am bringing the whole system in the active short circuit, take out the energy of a rotating motor. In some situation, an active short circuit and active discharge needs to be at the same time. In this situation, we are short the bottom 3 IGBT or silicon carbide, and we are pulsing with a lower gate emitter voltage the top IGBTs or silicon carbide. We are applying, for this situation, a 5 volt on the digital input pin and applying again our frequency to the input of the top gate driver. We are discharging our capacity, limit the current with the reduced gate emitter voltage, and we are able in the same way to short UVW on the motor. In this section, we want to talk about pre-testing our short circuit measurements. We are doing this in giving a high signal to our in plus of the bottom gate driver, and we are applying to our active discharge a positive signal. But now, instead of a frequency on the in plus, we keep here a high signal what is longer than the blanking time of our short circuit measurement. And in this case, we will receive an SO failure message on our SO digital output. Without use of extra hardware, the scale EV gate driver for automotive provide you active discharge, an active short circuit function, a pre-testing of our short circuit measurement. For more information, go to power.com.